Okay, section 6.5 is just applying systems of linear equations. So the good news for today, though, guys, even though I know you're seeing all the words right now, today's lesson is no different than everything we've done so far. Sometimes they're going to tell us a little story about our two equations to make it make sense in the real world, like how we could actually use these. And then other times we are going to have to create our own equations, which you guys have done before. So the good news is, though, that once you have your two equations, you get to choose whichever method you prefer to use or whichever method is most convenient for the equations that we're given. And that's something we'll talk about as we go through this today. So for our first example, it says, at a Boy Scout fundraiser dinner, Mr. Jones bought 2 adult meals and 3 child's meals for $23. Mrs. Gomez bought 4 adult meals and 2 child meals for $34. All adult meals are the same price, and all child meals are the same price. The following system can be used to represent this situation. Determine the best method to solve the system of equations, then solve the system. So even though we don't have to write the equations, we are going to go through this one as if we do. That way you guys can start to understand and see where these equations or these numbers are coming from. So the first one, they're talking about 2 different people here. Oh, my stylus. Oh, it's dead. That's okay. This just may not be very neat. So they're talking about 2 different people. The first person they're talking about is Mr. Jones. That's where his equation comes from. The second person they're talking about is Mrs. Gomez, and that's where her equation comes from. So let's see what they let x and y represent here, because that's something they did not do a very good job of telling us. So it says Mr. Jones bought 2 adult meals. So 2 adult meals, and we have a 2x. And then 3 child's meals, we have a 3y equals $23. Sorry, black was probably not the best choice there. So they let x equal adult meals, and they let y equal child's meals. Okay, and let's take a look and see if they did the same for the next equation. It says 4 adult meals, 4x, plus 2 child's meals, 2y, is 34. So that's how you would take it and set up your equation, because 2 adult meals times how much ever they cost, we don't know, plus 3 child's meals, 3 times how much they cost, will equal $23 total. And the same goes for the next equation. All right, so now that we have both of these set up, we need to determine the best method to solve this. Not that one is right or wrong versus, remember, we have graphing, we have substitution, and then we have the elimination that you guys have been working on. So for this one, since neither equation is solved for y, I'm not going to graph, because I can see dividing by 3. Dividing by 2 may not be too bad, but we're going to get larger numbers, so I'm not going to graph this one. I also am not going to use substitution because neither equation is solved for either x or y. So what I am going to use then is elimination, because my x's, my y's, my numbers, they're all in a straight line. So I look, my x's are not the same, my y's are not the same, but what I can do to my x, if I take this top equation and multiply it by 2, then these 2 terms will be the same. So let's distribute that. So we get 4x plus 6y equals 46. And then my second equation, I'm just going to write down 4x plus 2y equals 34. Okay, and then I'm going to take these 2 equations, and since my x's are the same, remember when they're the same, we subtract. So my 4x's cancel. 6y minus 2y is 4y. And then when we subtract 46 minus 34, we get 12. And then we need to divide both sides by 4, and we get y is equal to 3. Okay, so we determined the best method, and now we're solving. So now we have to find x. I'm going to plug it into the bottom equation. Why not? So, hang on, make this a little smaller. So 4x plus 2y, but we just found y was 3, equals 34. So 4x plus 6 equals 34. So we have to subtract 6 from both sides. So 4x is equal to 28. Divide both sides by 4. And we get x equals 7. So that means our ordered pair would be 7, 3. But let's see what that means in relationship to this problem. They bought 2 adult meals. So we already know how many adult meals they bought, and that's x. So that means an adult meal is $7, and a child's meal, is $3. Okay? And don't do my pet peeve and put 7 and then the dollar sign at the end. Okay, we say $7, but we write that dollar sign at the beginning. Okay? All right, so take a moment, try this your turn, and then come back and check it when you're finished. All right, so after reading this problem, we have two choices. I think both would be pretty similar in solving. One is to do elimination, and actually for this one I might do both. That way you guys can, depending on how you did it, you can check your work. I doubt anybody's going to graph this one just because the y's aren't already solved. So the first one I'm going to do is I will do the elimination method. So the first equation becomes 2x plus 4y equals 20. And then 2x plus 3y equals 17. Since they are the same, we are going to subtract. So we get 1y equals 3. So basically just y equals 3. Now I'm going to go ahead and substitute that into my original top equation. So x plus 2 times y, which is 3, equals 10. So x plus 6 equals 10. If we subtract 6 from both sides, 10 minus 6 is 4. So we get the ordered pair 4, 3, 3. All right, but say you wanted to solve this using substitution. Well, for substitution, my top equation, x, looks easier to solve for. So that's what I'm going to do. So I'm going to subtract 2y from both sides. So x is equal to 10 minus 2y. And then everywhere I see x in my second equation, I'm going to plug that in. So there's my x plus 3y equals 17. So let me plug my 10 minus 2y in there. So 20 minus 4y plus 3y equals 17. So combine like terms. So I get a negative 1y equals 17. And then subtract 20 from both sides. Negative 1y equals negative 3. Divide both sides by a negative 1. And hopefully you still got y equals 3. Now I guess I will. I will show substituting it back in. So x equals 10 minus 2 times 3. So 10 minus 6. X is equal to 4. So we still got the same ordered pair 4, 3. Oh my gosh, did it again. No matter which method you chose to use, because each were equally easy in this case. All right, are we ready to write our own equation? All right, it says Ace Car Rental rents a car for $45 a day and 25 cents per mile. Star Car Rental rents a car for $35 per day, and that should, this should say 30 cents a mile. That should be, you know what, let's make it better. That should be a dollar sign instead of the 4. Oh gosh. There we go. It's there all along. 30 cents per mile. After how many miles will the cost of renting a car at Ace Car Rental be the same as the cost of renting a car at Star, my goodness, what happened when I typed this? At Star Car Rental. Okay. So the first thing we're looking at is we have two different car rental places. We have Ace, and that's his sentence. And then we have Star, and there's its value. So we're going to write Ace's first. Okay. So Ace. It says $45 a day and 25 cents per mile. They did not tell me what the total cost was. So in this case, Y is going to be my total cost. And how do I get my total cost for that day? Or for the time we're doing it? So it's 25 cents per mile, so 0.25x plus 45. Because I only have to pay that $45, because it's saying, let me back up a little bit, since this is after how many miles will the cost be the same. So we're only renting the car for one day. So then we have to do the same thing for Star. We don't know our total, but we do know it cost 30 cents a mile plus $35 a day. Okay, so, and now off to the side, because if this is a keystone, you have to write what they are. So Y is total cost. Sorry, I should have made sure my stylus was charged. And then X is number of miles. All right, so now we get to solve these. I know that sometimes this is not your favorite ones to do when they're each equal to Y. But if this top equation says Y is equal to that, I'm just going to substitute that in there. So I get 0.25 x plus 45 equals 0.3 x plus 35. And then we're just going to solve this. So I'm going to subtract 25 cents from both sides. So when I do that, I get 45 equals 30 cents minus 25 cents is 5 cents, so 0.05x plus 35. And then I'm going to subtract 35, but I'm running out of room, so I'm not going to show the subtraction. But when we do subtract, 45 minus 35 is 10 equals 0.05x. And let's bring this calculator up. Oh my goodness. So we get 10 divided by 0.05. Wow, so x is 200. Now remember, we said x was miles, so 200 miles is how far somebody would have to travel to make the cost be the same no matter which company you chose. Okay? And we could get into this a little more and determine which one is cheaper for less than 200 miles and which one is cheaper for more than 200 miles, but that's for another time. All right, so I can see before you do this your turn, there's another typo. That should be 75 cents per day. There we go. All right, so take a moment, try to do this one, and then come back and check. And I'm probably not going to talk the whole way through it, but you can check through my work then. So there's our two equations. You can see I let y equal the total cost and x equal the number of days. So just as the same as the last one, since they both equal y, I'm just going to substitute the top one in for y into my second equation. So I'm going to subtract 50 cents from both sides. So 75 cents minus 50 cents is 25 cents. And then subtract 1 from both sides. So 2 minus 1 is 1. Divide both sides by 0.25. Should give us 4, but I'll show you in case you don't believe me. 1 divided by 0.25 is 4. So then we have to say, okay, did we find what they wanted? After how many days? X, we said, was the number of days, thank goodness, so we are done. 4 days. Now, if they wanted the price after that, all we have to do is substitute that into either equation to get y. Okay, so hopefully that makes sense, but always feel free to go back and watch any part of the video you need to.